At first glance, OL geometry diagrams appear to be a chaotic mess of intersecting lines and stacked polygons. Success relies on looking past this complexity to find the basic, foundational shapes hidden within. When we pull the diagram apart, the drawing resolves into three manageable components: a set of parallel lines, a standalone triangle, and a simple parallelogram. Exam mastery is achieved by identifying these isolated shapes and applying the specific rule that governs them. We begin with the foundational angle rules. Angles on a straight line add up to 180 degrees, while angles around the single point total 360 degrees. These rules provide the basis for analyzing parallel lines cut by a transversal. Look for specific visual patterns when lines are parallel. The Z shape identifies alternate angles, underbyttekoningar. The F shape shows corresponding angles, åttekoningar. The U shape indicates allied angles, neakoningar. In this triangle, extending one side creates an exterior angle. This exterior angle is always equal to the sum of the two interior opposite angles, expressed as x equals a plus b. In your exam, the presence of parallel line symbols is a direct instruction to search for these Z, F, and U patterns. Triangle congruence, or mukono oringisaivo, requires meeting one of four specific conditions to prove two triangles are identical: side, 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 angle, side, angle, side, or right angle, hypotenuse side. Let's examine the side angle side condition using these two triangles. For this condition to be valid, the matching angle must be positioned exactly between the two matching sides. If the angle is located anywhere else, the triangles cannot be proven congruent using this rule. Be careful with right-angle triangles. While they often suggest the right-angle hypotenuse side rule, the given data might actually require you to use the angle side condition instead. Avoid making assumptions based on how a shape looks. You must confirm the exact sequence of properties provided in the question before selecting a theorem. A parallelogram, or inegaram, has many characteristics, but you only need to prove one specific condition to identify the shape. If you prove that one pair of opposite sides is both equal in length and parallel, the quadrilateral is mathematically locked into being a parallelogram. The midpoint theorem, Narupuli tetram, governs lines that connect the center of triangle sides. This line is always parallel to the base of the triangle and measures exactly half of the base's total length. Identifying midpoints in a diagram allows you to establish parallel relationships without needing to calculate any angles. Area questions rely on shapes on the same base between parallel lines, ore adi, ore samantra korals. Here, the triangle and parallelogram share a base. If base and height remain constant, the triangle's area is exactly half the parallelogram's, regardless of how it's stretched. Tracing the lines to find a common base provides the evidence needed to solve area-related exam problems. The Pythagorean theorem, Pythagoras theorem, applies to right-angled triangles. Identify the hypotenuse by looking directly across from the 90-degree symbol. This longest side completes the equation BC squared equals AC squared plus AB squared. Apply a four-step strategy for every problem. Read the provided data, scan for hidden shapes, select the theorem from this framework, and state the formal mathematical reason. Use this map to organize your approach to geometry. By categorizing the diagram into these specific rules, you can approach your OL exams with confidence. Good luck.